All right, so for lesson 2.2, we're going to learn about solving inequalities using addition and subtraction. We're going to learn how to solve inequalities using addition and subtraction, and we're going to learn how to solve some real-life problems too. So, just like when we were solving equations, you can use the properties of equality to solve equations. We can also use them to produce equivalent inequalities. So equivalent inequalities have the same solutions. So here's our addition property of inequality. Adding the same number to each side of an inequality produces an equivalent inequality. So we're allowed to add the same number to both sides. You can see it here with numbers. If you have -3 is less than 2, that's true. And if you add 4 to both sides, we get 1 is less than 6. So you can add the same number to both sides of an inequality and it's still true. And you can see algebraically, we say the same thing down here. If you add the same number to both sides of an inequality, it will remain the same, remain true. Okay, so how are we going to use that? Well, here we have an inequality where x is not by itself. We got x minus 6 greater than or equal to -10. So to get the x by itself, we would need to do the inverse of subtracting 6. So we're going to add 6 to the left side of the inequality. We're going to add 6 to the right side of the inequality. And we get x is greater than or equal to -10 plus 6 is -4. So then to graph our solution, we're going to make a circle at -4. But since we have the equal to sign here, that means -4 can be a solution. So we're going to fill in that circle so it's a closed circle, showing that -4 is a solution. And then where are the numbers greater than -4? Over here to the right. So we draw our arrow to the right. And you can see that it matches the right arrow saying x is greater than -4. So our solution is x greater than or equal to -4, and that is the graph of our solution set. Okay, so go ahead and try these, and then you can take the video off pause to then see how you did. So for number 1, we're going to add 2 to each side of the inequality, and we get b is greater than -9 plus 2 is -7. So b greater than -7. That would be an open circle at -7. Greater than is the numbers to the right. For number 2, m minus 3, we're going to add 3 to both sides of the inequality, and we get m is less than or equal to 8. So we would we have the equal to sign, so we're going to do a solid circle at 8. Less than 8 is to the left. Then for this last one, we have y minus 1/4. So we're going to add 1/4 to each side of the inequality. So then 1/4 plus 1/4. 1/4 plus 1/4 is 2/4, which reduces to 1/2. So we get 1/2 is greater than y. You flip that around, it's y is less than 1/2. So we would make an open circle at 1/2, and then our line will be going to the left because that's where the y values are less than 1/2. So this is the subtraction property of inequality. It's basically just like the addition property of inequality, except we can subtract the same number from both sides. And whether you see it algebraically or numerically or hear it in words, the same is true. Subtracting the same number from each side of the inequality produces an equivalent inequality. And that's the property we use to solve when we have addition and we need to subtract from both sides. So example 2. Part A, y plus 8 is less than or equal to 5. In order to solve for y, we need to subtract 8 from each side of the inequality. And we get y is less than or equal to 5 minus 8 would be -3. So then we need to put numbers on our number line. We need -3, so say 0, 1, 2, 3, -1, -2, -3. And then to graph that, we're going to we got y less than or equal to -3. So at -3, we're going to have a closed circle showing that -3 can be a solution. And then we also are going to go to the left where the y values would be less than -3. On part B, we've got -8 is less than 1.4 plus m. To get m by itself, we would need to subtract 1.4 from both sides. So we would have m on the right side, and -8 minus 1.4 would be -9.4. So -9.4 is less than m. That means that m is greater than -9.4. So we need to put some numbers on here. So let's say if this was -9.0, this would be right here, -9.1, -9.2, -9.3, -9.4, -9.5, and so on. And we want m to be greater than -9.4. So no equal to sign, so that means we're going to have an open circle at -9.4. M is greater than that, so our arrow will go to the right. Okay, pause the video here and try these problems, and then play again when you want to see how you did. In order to solve number 4, we're going to subtract 5s from both sides. And we get k is less than or equal to -8. So if we had, say, -8, -7, -6, we just put the numbers on our number line. Less than or equal to -8 means solid circle at -8 because -8 is a solution. And then to the left where the numbers are less than -8. For number 5, we're going to subtract 1/6 from each side of the inequality. That will get the z by itself on the right side. 5/6 minus 1/6 is 4/6. That reduces to 2/3. So 2/3 being less than or equal to z is the same as z being greater than or equal to 2/3. Okay, so let's see. If this, let's say 0 is here, and we can say that's 1/3, 2/3, 3/3 would be 1. So then -1/3, -2/3, -1. Z is greater than or equal to +2/3. So solid circle at +2/3. Arrow going to the right where numbers are greater. Number 6. Subtract 0.7 from each side of the equal sign. And we get P is greater than, let's see, they're both negative, so add them together. This would be -3.0. So P greater than -3. To graph that, we'd have an open circle at -3. Greater than is to the right. Okay, so last big example, example 3. We have a circuit that overloads at 1,800 watts of electricity. You plug in a microwave that uses 1,100 watts. And now for part A, we want to write and solve an inequality that represents how many watts you can add to the circuit without overloading it. Okay, so right now our circuit has, it overloads at 1,800 watts. So that means that our total watts has to be less than 1,800. because if it's at 1800, then the circuit overloads. So right now, the microwave would use 1100 watts. So 1100 watts plus the number of watts we can add would have to be less than 1800. So there I wrote my inequality. So now I just need to solve it. So if I subtract 1100 from each side, I would get n is less than 700. So there is my solution. I wrote it, I solved it. So then part B says, in addition to the microwave oven, which of the following appliances can you plug into the circuit at the same time without overloading? So we're looking over here. So it has to be less than 700. So I can't do the toaster, that's more. I can't do the hot plate, that's too much. So all I can do, I can plug in the blender and the clock radio. Because then I would still be, those two would be less than 700. Okay, so check to see if you can do this one. In this situation now, the microwave uses only 1000 watts. Does this allow you to have the microwave and the toaster plugged in at the same time? So if the microwave is 1000, what was the toaster? Toaster was 800. So can we add 800 on there? The toaster, 800 watts. So if the microwave was only 1000 watts, we would subtract 1000 from each side of this inequality, and we would get, and the number that you can add on has to be less than 800. So can we plug in the toaster? The answer would be no, because 800 is not less than 800. That would actually overload the circuit.